All right, so let's finalize this. Strangely, the assignment operator, we can make a comment here. Disable assignment for this class. Okay, how you do this? Declare it. I'll declare it now. Just have trouble typing here. Rational const reference other, just like this. So again, assignment operator is provided to us for free. What free version of the assignment operator, which took place right here, what this operator did, it was making bitwise copy, exact bitwise copy of ret 3. Obviously, the negated version produced temporary object, right? So right here, recall operator operator minus this operator right here. It produced a temporary object, returned temporary object from this operator, and the temporary object was used to copy everything bit by bit into this object, ret 3. And so therefore, the assignment worked. And we were able to compile and run and see that it worked and everything was negated. But if I want to disable assignment operator for my classes, you can declare it private. This is the signature that you use. And by the way, see how this is just a declaration? I will not even provide implementation for this privately declared operator. I'm completely disabling now, intentionally disabling assignment of one rational number to another rational number, which is obviously an irrational attempt. The users will be not very happy about this. But what is going to happen is just no one will be able to assign anymore, right? So it says everyone will be getting this error: cannot access private member declared in class rational. This assignment, see declaration of this operator, right? So the declaration of this operator, reasonable, right? So then, if I say, okay, right, so we just demonstrated that we can disable. And by the way, this way, you can disable any operator. If you want to disable something else, you can declare it private. You can also declare private constructors. Like, for instance, you can declare you don't want to provide any constructors to your object, but you can declare a constructor private. And the only way to create your object would be to add a static function to your class and create it there, because it will be part of the class. It will still be able to use a private version of the constructor. So a lot of things can be intentionally made private. So this is an interesting attempt to before. So this is how we took away essentially the default version of assignment operator. But let's go to an actual normal version of the assignment operator. So this would be the way to disable it, but if we didn't want to disable it, let's define it. Okay, so we'll define it. One thing is that the assignment operator can only be overloaded as member function. Quite honestly, I forgot the reason why, but my guess would be is that obviously the assignment operator needs to access pretty much the entire object. So but you can research why exactly the assignment operator has to be a member function. I read about it and I forgot. I don't remember why. So I always kind of, when I get to this presentation and I talk about this in class, I kind of say, I should have researched why exactly this required to be a member. So we can talk about it next week if I remember to look it up. All right, but anyway, so this is the signature. So what happens is this. We won't obviously allow things such as this. right? So this is obvious. This is the purpose of the assignment. But we also would like to allow this. Recall that in C and C++, assignments can be chained because those are just normal. So for example, if I say integer x equals 1, and then I can say integer y equals integer x. That's obvious, right? And then I'll create integer z, and I should be able to say integer z equals y. And so these are obvious cases, but also I should be able to do this. What happens here is that the association of the assignment operator is right to left. And so the way this is interpreted is this. Okay? This is how the grouping works with assignments. So first, the rightmost assignment takes place. Then the result of this rightmost assignment is given to this guy, and then this assignment takes place. So because of the right to left association with the assignment operator, essentially this is possible. And what happens is that, so I will just rewrite it the second time, is that the value of y will be assigned to x. But C++ standard also says that the arithmetic value of an assignment is the value that is being assigned. So if y was 5, right? If we made this, I don't know.
Can you reverse that?
Yeah, I'm just.
You had x equals 1, then you had y equals x.
Let me just. Well, yes, I can reverse all of this, but what I'm doing is just I'm using those three variables to demonstrate that this syntax is possible, regardless of the order in which I do this. Nothing relevant to a particular order. What should be happening here is that, of course, this will be happening, and of course, 5 will be stored in x, number 1. Number 2, the value that is just being assigned, we know for a fact, was 5, integer 5. So the value of this entire expression is 5. And therefore, 5 will be assigned to z. To provide the same semantics to our own classes, that we can use expressions like this, we have to define operator equals, that it returns a reference to the object that was just assigned something. By the way, the bitwise copy of this, which was given to us for free, actually worked perfectly fine. There's no need to do this, but we'll just do this right now for the demonstration purposes. So there's just like, it's unnecessary, but we'll do it. So here's our assignment operator, right? Copy and paste. This the assignment operator has to be defined as a member of our class. So we follow the this whole rule. And what needs to happen is this. Of course, it's sort of like trivial. We just say, all right, so we have an object, and we have another object. And so what we're going to be doing is basically saying numerator of our own equal other numerator, right? And similarly, denominator does the same thing. We just do this, kind of dumb assignment of two integers. But here is something. To be able to chain it like this, when this happens, somehow we need to be able to provide this, to provide enough for this part to be happy. This part will be happy if somehow we return a reference to this object. right? Because if we provide a reference to this object from our assignment operator, then a reference can be used as well as the original object, and therefore ret1 will just say, okay, give me your numerator and denominator, and finally will assign to its own right here, right? So this can be chained. So that's why it's very simple. We just say we already provided that this operator return type is reference to rational, and what we return back is basically we have the this pointer, right? The this pointer is the pointer that tells us this is us, and we want to essentially recall that this is a member function operator. So therefore it's invoked on this guy, right? So this operator equals this. So this guy becomes other. This guy is this when the function is invoked. However, this is a pointer. To be able to convert pointer to a reference, we need to dereference the pointer. Let's save this.